Hello everyone, this is Dr. A classes for BTech students. This lesson, titled Our Planet Earth, is the second topic in engineering geology. This lesson discusses Earth and planetary science. It is designed to provide BTech civil engineering students with essential geological knowledge. Learning objectives of this course is understanding the formation and evaluation of the solar system and the Earth, explaining the major geological processes shaping Earth's surface, identifying and describing the different layers of Earth, learning the composition and characteristics of Earth's atmosphere, hydrosphere, and biosphere, exploring the wonders of our home planet. What is Earth? It is the third planet from the Sun. It orbits the Sun at a position that is neither too close nor too far, allowing for liquid water to exist on its surface, uh, which is a crucial factor for sustenance of life as we know it. As we are aware, the Earth is the only planet to harbor life. It is the only celestial body we know of that supports a diverse array of living organisms. Earth is the fifth largest planet compared to the gas giant like Jupiter and Saturn. Earth is relatively small. However, it is the largest of four terrestrial planets, that is Mercury, Venus, Earth and Mars, which are primarily composed of rock and metal. Earth is approximately 4.54 billion years old, having formed from a swirling cloud of gas and dust in the early solar system. Its diameter is roughly 12,742 kilometers. Mass of Earth has a substantial mass of about 5.97 into 10 to the power 24 kilograms, which contributes to its gravity and the ability to hold atmosphere. Planets in our solar system revolve around the Sun in a counterclockwise direction. Planets' orbits are not perfectly circular but elliptical, meaning their distance from the Sun varies throughout their orbit. The time it takes for a planet to complete one orbit around the Sun is called its revolution period. Planets also rotate on their axis, which is what causes the day and the night. Origin of Earth and the solar system. Earth is believed to have been formed around 4.5 to 5 billion years ago. This means our planet has a long and fascinating history. Earth's origin is intricately linked to the birth of our entire solar system. Observation of other stars and their planetary system provide clues about how planetary system formed and evolved. This information helped scientists refine their understanding of Earth's origin. Scientists studied the rocks of Earth, particularly those with radioactive elements. By measuring the decay of these elements, they estimated the age of the rocks and consequently the age of Earth. Meteorites are remnants of the early solar system. By analyzing their composition and age, scientists gained insight into the conditions that prevailed during the Earth's formation. Theories on the origin of Earth. Origin of Earth is still the matter of debate among the scientists and the scholars. There are multiple theories, however, on the formation of the solar system, which is a complex process and no single theory fully explains it. Scientists continue to study and refine their understanding of how the solar system was formed through observation, simulations, and new discoveries. Some of the most widely acceptable theories are nebular hypothesis. Immanuel Kant and Pierre-Simon Laplace hypothesized that the solar system was formed from a large rotating cloud of gas and dust. that is nebula, which collapsed and formed the Sun, while the remaining material coalesced into planet. Accretion hypothesis. According to this hypothesis, Earth was formed through the gradual accumulation of dust, rocks, and gas. Collisions between planetesimals generated heat, leading to the differentiation of Earth's layer. Other theory is capture theory, which proposes that the Sun's gravity captured wandering celestial bodies to form the solar system. Another theory is modern planetary formation models incorporating elements of nebular and accretion hypothesis, suggesting gravitational forces, angular momentum, and material aggregation in the planet formation. Stages in Earth's formation. Initial nebular collapse. A giant molecular cloud collapsed under its own gravity, forming a spinning disk of gas and dust. Formation of protosun. The center of the disk became dense and hot, igniting nuclear fusion to form Sun. Planetary accretion. Dust particles collide and stuck together, forming planetesimals. These planetesimals combine to create protoplanets, including Earth. Differentiation, heat from the radioactive decay, and impacts cause Earth to partially melt. Heavier elements like iron and nickel sank to form the core, while the lighter elements formed the mantle and the crust. The nebular theory provides a compelling explanation for the formation of our solar system, which is widely accepted by scientists today. Key elements of the nebular theories are formation of a giant molecular cloud, which is the starting point for the star formation. These vast clouds of gas and dust are the birthplace of stars. Within these clouds, gravity pulls matter together into a denser clumps. As these clumps become more massive, their gravitational pull increases, leading to further collapse. As the clumps collapse, it, it, it starts to rotate. This rotation causes the material to flatten into a disk shape. At the center of this rotating disk, a protostar forms, which is a young developing star that is still gathering mass. The remaining material in the disk forms a protoplanetary disk, a swirling ring of gas and dust surrounding the protostar. Within this protoplanetary disk, dust particles collide and stick together, gradually forming larger and larger objects, eventually leading to the formation of planets, moons, asteroids, and comets. Thus, the formation of planetary system is believed to be a natural result of a star formation. A Sun-like star usually takes approximately 1 million years to form. The protoplanetary disk evolving into a planetary system over the next 10 to 100 million years. Evidence supporting Earth's age and formation. Some of the evidence discussed hereafter provide compelling support for the nebular theory as the most likely explanation for the origin of our solar system. Radiometric dating. By analyzing the decay of the radioactive isotopes in rocks from the Earth and the Moon and the meteorites, scientists have determined that these objects are approximately 4.5 billion years old. This age aligns with the timeline predicted by the nebular theory for the formation of the solar system. Cosmic microwave background radiation. The cosmic microwave background is faint radiation left over from the Big Bang. Its existence and the characteristics strongly support the idea that the universe originated from a hot, dense state, which is a fundamental tenet for the nebular theory. Presence of heavy element. The abundance of heavy elements like carbon, oxygen, and iron in the universe can be explained by the nebular theory. These elements are created in the cores of stars through nuclear fission and are released into space during supernova explosion. The presence of these elements in our solar system suggests that it formed from material enriched by previous generations of stars. Evolution of life on Earth. The Earth initially had a barren, rocky, and hot surface with a thin atmosphere of hydrogen and helium. Over the time, this atmosphere was replaced by volcanic outgassing, producing water vapor, carbon dioxide, nitrogen, and other gases. The planet gradually transformed from a rocky, barren, and hot environment to a beautiful, habitable planet with, with the ample water and a diverse atmosphere. Life perhaps evolved between 3.8 billion years and the present day. The origin and evolution of life on Earth began in its early phases. Initially, the Earth's surface and atmosphere were not conducive to the development of life. It is believed that life started as a series of chemical reactions that generated complex organic molecules. These molecules assembled into structures capable of replication, converting non-living matter into living organism. Evidence of life that existed on this planet during different periods is recorded in rocks in the form of fossils. The study of microscopic structure of ancient fossils found in geological formations much older than 3.5 billion years closely resembles the present form of blue-green algae. It can therefore be presumed that life perhaps began to evolve around 3.5 to 3.8 billion years ago. Earth's internal structure. Earth has a solid rocky outer layer called the crust. Beneath this crust is a thick semi-solid layer called the mantle. At the center of the Earth is a solid inner core surrounded by liquid outer core. Earth's dimensions. Our planet Earth is not perfectly spherical, but it is an oblate spheroid. That means it is flattened at its poles and bulged at equator. Earth's equatorial diameter is 12,757.776 km and the polar diameter is 12,713.824 km, thus having a difference of 43.952 km. The surface area of our planet is 510 into 10 to the power 6 square kilometer, of which about 29% is land and the rest is ocean. The mean density of Earth is 5.517 gram per cubic centimeter. The volume of Earth is 1.083 into 10 to the power 27 cubic centimeter and the mass is 5.975 into 10 to the power 27 grams. Earth's surface relief. The Earth has widely varied topography with towering mountains and deep ocean trenches shaping the planet's surface. The Earth has lofty mountain ranges like Himalayas, home of Mount Everest, the highest point on the land at 8,848.86 meters above mean sea level. In contrast to the mountains, there are deep ocean trenches like the Mariana Trench reaching a depth of 10,984 meters below mean sea level. The average elevation of land above sea level is 840 meters above mean sea level. The average depth of ocean is 3,682 meters below mean sea level. The Dead Sea is the lowest point on the land, situated at 430.5 meters below mean sea level. Earth's atmosphere. The Earth's atmosphere is made up of nitrogen 78%, oxygen 21%, and other gases 1%. The atmosphere protects the Earth from harmful radiation from the Sun. The Earth's atmosphere is divided into several layers, each with distinct characteristics. From the surface upward, these layers are troposphere. This is the layer closest to the Earth's surface, extending up to about 7 to 15 kilometers, depending on the latitude. It's, it is where weather occurs, containing most of the atmosphere's mass and water vapor. Temperature generally decreases with altitude in the troposphere. The next layer above the troposphere is the stratosphere, extending from up to about 50 kilometers. The stratosphere contains the ozone layer, which absorbs harmful ultraviolet radiation from the sun. Temperature increases with altitude in the stratosphere. Mesosphere. Extending from the stratosphere to about 85 kilometers, it is the coldest layer of atmosphere with a temperature reaching as low as minus 90 degrees Celsius. Then is above mesosphere is thermosphere extending up to about 600 kilometers. The thermosphere is characterized by increasing temperature due to the absorption of solar radiation. The International Space Station orbits within this layer. Exo Exosphere is the outermost layer of the atmosphere, gradually merging with outer space. It is a region of very low density where molecules can escape into space. Earth's hydrosphere. The hydrosphere encompasses all the water present on Earth, including oceans, seas, rivers, lakes, groundwater, glaciers, and water vapor present in the atmosphere. Oceans cover about 71% of the Earth's surface and holds 97% of the Earth's water. Fresh water includes river, lakes, groundwater, and glaciers constituting about 3% of the total water. Atmospheric water includes water vapor, cloud, and precipitation. Importance of Earth's hydrosphere. The hydrosphere is essential for life on Earth, integral to hydrological and geological processes, influences weather pattern and global climate system. Earth's biosphere. It is part of Earth where life exists, encompassing all living organisms and their interactions with the lithosphere, hydrosphere, and atmosphere. The biosphere consists of flora, plants, trees, algae, and other photosynthetic organisms that produce oxygen and form the base of the food chain. Fauna, animals ranging from microscopic organisms to large mammals that rely on plants and each other for sustenance. Microorganisms, bacteria, fungi, and other tiny organisms that play crucial roles in decomposition and nutrient cycle. Earth's climate. Climate is not about the weather today or tomorrow, but rather the long-term average weather condition in a particular region. This includes factors like temperature, precipitation, humidity, wind, and sunshine. The Earth's climate is influenced by several factors. The sun, which is the primary source of energy for Earth climate, it provides the heat that derives weather pattern and the water cycle. Atmosphere, which plays a crucial role in regulating Earth's temperature, it traps heat from the sun and helps to distribute heat and moisture around the globe. Oceans, which absorbs and store a vast amount of heat from the sun, influencing global temperature and weather pattern. They, they also play a major role in water cycle, transporting heat and moisture around the planet. Earth's climate is changing, and this is having a significant impact on the planet. This climate change is primarily caused by human activities such as the burning of fossil fuels, which release greenhouse gases into the atmosphere. Earth's resources. The Earth is home to vast array of natural resources. These resources include minerals, water, and forest. The Earth's resources are essential for human survival and well-being. Earth's resources are the materials and substance that we obtain from planet to support life and human activities. The Earth resources can broadly be categorized into renewable and non-renewable resources. Renewable resources, these resources can be replenished naturally at a rate that is equal to or greater than the rate at which they are used. Examples include solar energy is a virtually inexhaustible resource. Wind power is another renewable energy resource. Water is a finite resource, though the water cycle ensures its continuous renewal. Biomass or organic matter from plants and animals can be used as a renewable energy resource. The, no, the non-renewable resource, these resources are formed over geological timescales and are depleted faster than they can be replenished. Examples include fossil fuels such as coal, oil, and natural gas are non-renewable resources formed from the remains of ancient organisms. Minerals and metals like iron, copper, and gold are extracted from Earth's crust and are finite resources. The sustainable use of Earth's resources is crucial for the well-being of current and future generations. It requires careful management, conservation, and the development of alternative renewable resources. Self-assessment questions. At the end of the presentation, these are self-assessment questions. Go through each question carefully. Answer these questions based on your understanding of the topic. Review any concept you are unsure about. The questions are: discuss Earth's internal structure and composition. Write a note on origin of Earth and the solar system. What is the estimated age of Earth and how is it determined? Define the lithosphere and asthenosphere. Write an account on mineral resources of India. Thank you for joining this lesson on engineering geology today. Hope you found this presentation informative. Now, don't forget to like and subscribe the channel Dr. A Classes for more engaging lessons on core subjects of civil engineering. Thank you.